Digital logic, or Bolean algebra, is a subfield of math that only allows variables to take on one of two values, 0 or 1. Now, it is common to interpret these symbols as being false and true. And there are certainly applications of this sort of logic if you use these interpretations. But ultimately, these are just symbols, and the operations that you use will be the same regardless of what symbols you use. In this class, we will use 0 and 1, as is common in most courses on computer organization and architecture. 3 Boolean operations that you are no doubt familiar with from high-level programming languages are not, and finally, or. Now, if I have a Boolean variable a that can take on a value of 0 or 1, then I will denote the negation of a, or not a, as a with a bar over it. This symbol may be different from what you've seen in other classes or in programming languages, but it is what we will use in this class. If a is 0, then the negation of a is 1. And if a is 1, then the negation of a is 0. It is simply the opposite. Now what I've drawn here is referred to as a truth table. I list out all possible values of input variables, and then I determine the value of some expression of the input variables. To do the same with and, I need to have 2 distinct variables. Now, a could have a value of either 0 or 1, and b could also have a value of 0 or 1. But because a has 2 possibilities for each possibility of b, I need to repeat b's values, and then also repeat a's values when I switch b's values. So for the 2 possible values of a and b, I end up with 4 possible combinations of those values. Now in this class, we will denote logical AND using what looks like a multiplication operator. What this operator asks is it the case that both of my inputs are 1? That means that if both are false, the answer to that question is false, and I put a 0 here. If one of them is true and the other is false, well, then the answer to that question is still false, regardless of the order of those 2 values. I only have an answer of true if both of those variables are true, or 1. So here we have a truth table for logical AND. The third operation, which you are certainly familiar with, is OR. And this will be the inclusive version of OR. Let's start by writing out possible values of the variables, and then write out how we will represent OR in this class using a plus sign. Now, although I'm using a plus sign to indicate logical OR, I am not simply adding these bits. Rather, I will interpret this operator as asking the question, is it the case that at least one of these 2 variables is a 1? So if they're both 0, then the answer to my question is false, and I put a 0 here. If a is 1 and b is 0, then at least 1 is a 1, so I put a 1 as my result, and that holds true regardless of the order of the variables. Now this last row requires some thought. The question is it true that at least one of the variables is true? Well, if they're both 1, then yes, at least one of them is a 1. So I will put a 1 here, and this is the reason that this is an inclusive OR operation. In common spoken English, we might also interpret the word OR as being exclusive, meaning that if one thing or another is true, then I would not want to consider a situation true if both of them were true. We sometimes use XOR to denote this operation, which has the following truth table. First, we'll write out possible values of A and B. And then, to distinguish XOR from inclusive OR, I will use a plus sign in a circle. This is also fairly common, although not a universal notation. It is what we will use in this class, however. Now, the truth table for XOR is the same as that for inclusive OR until the last row. So, if neither variable is true, then the result is false. If exactly one is true, then I will consider those to be true results. But if both of them are true, then I will not consider that to be true. So, not and or are 3 common logical operators which you've used in high-level programming languages. XOR is one that you've likely been exposed to, and in future videos we will learn about other operations and of ways of combining these operations.